Hello students, in today's class, let us first derive the equation of the plane passing through three non-collinear points. So here, non-collinear points means those points which are not lying on the same line. So we are considering 3 points on the plane and these 3 points are not lying on the same line. Okay, so we have considered 3 points R, S and T. And you can see all the 3 points are not lying on the same line. Let the position vector of the point R be A and position vector of the point S be B and the position vector of the point T be C. And from this you can see you have 2 vectors given in the plane, that is vector Rs and vector Rt. Let us first write this data. Let R, S and T be 3 non-collinear points on the plane with position vector A, vector B and vector C respectively. We have then the vectors Rs and Rt is in the given plane. Therefore, if I take a cross product between these 2 vectors, vector Rs and vector Rt, you have the resultant vector which is perpendicular to the plane. So, I write that resultant vector as vector Rs and vector Rt. Therefore, the vector Rs cross Rt is perpendicular to the plane containing the points R, S and T. Okay, after this I am going to consider the another point P on the plane whose position vector is vector R. So let R be the position vector of the point P on the plane. With this data, we will be able to find the equation of the plane passing through 3 non-collinear points by using the equation. Means by using, already we have learned an equation. Which equation is that? Is in the previous class I have already derived that. That is the equation of the plane passing through a given point and perpendicular to a vector. If you remember, we have derived where the equation of the plane will be passing through a point A and will be perpendicular to the vector n, and we got the equation as vector AB dot vector n is equal to 0. We are going to use this in order to find the equation of the plane passing through 3 non-collinear points. Okay, so therefore the equation of the plane passing through the point R and perpendicular to the vector vector rs cross vector rt is given by, okay, so as I said, we have already derived the equation of the plane which is passing through the point A and perpendicular to vector n. So here we are going to use the same concept. Here this plane is passing through the point R and perpendicular to vector rs cross rt. Therefore now this becomes vector rp dot. This becomes equation of a plane passing through the point. Which point here? Here the point is R and perpendicular to the vector. There in the derivation in the previous class the vector was vector n. Here it is perpendicular to which vector? Vector rs cross vector rt. Therefore vector rs cross rt is equal to 0. This we have written from the derivation which we have already learned in the previous class. So there we wrote that vector ap dot vector n is equal to 0. That is the plane which was passing through the point A and perpendicular to n. Here in this the plane is passing through the point R and perpendicular to the vector rs cross rt. So now vector rp can be written as vector op minus vector or dot vector rs can be written as vector os minus vector or cross vector rt can be written as vector ot minus vector or is equal to 0. Vector OP. What is vector OP? Vector OP is given by vector R. So vector OP is vector R minus vector OR which is vector A dot. Next vector OS which is vector B minus vector OR, it is vector A cross vector OT minus vector OR. Vector OT is vector C minus vector OR is vector A is equal to 0. Okay, I am going to rewrite this. So this will be equal to vector R minus vector A dot vector B minus vector A cross vector C minus vector A is equal to 0. This is your vector form of the equation of the plane passing through 3 non-collinear points. Vector form of the equation of the plane passing through 3 non-collinear points. Now let us derive its Cartesian form. So here vector r is equal to xi cap plus yj cap plus zk cap and vector a is equal to x1i cap plus y1j cap plus z1k cap. Vector b is equal to x2i cap plus y2j cap plus z2k cap and vector c is equal to x3i cap plus y3j cap plus z3k cap. Therefore here the Cartesian form. In order to find its Cartesian form, we should know what is vector r minus vector a, then vector b minus vector a and vector c minus vector a. So what is vector r minus vector a? We know how to subtract two vectors. So vector r minus vector a will be given by x minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap. Then vector b minus vector a will be equal to vector b minus vector a will be equal to x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. And vector c minus vector a will be equal to x3 minus x1 I cap plus y3 minus y1 j cap plus z3 minus z1 into k cap. Okay, therefore the Cartesian form for the equation of the plane passing through three non-collinear points will be given by determinant of x minus x1, y minus y1, z minus z1. In the second row, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, and z3 minus z1 in your third row, which is equal to 0. So this is the Cartesian form of the equation of the plane passing through three non-collinear points. Now let us solve few problems on equation of the plane passing through three non-collinear points. So let us solve the first problem. Here we need to find the equation of the plane that is passing through 3 points. So they are given 3 points. Let us find. So here I am going to use the Cartesian form of the equation of the plane passing through three non-collinear points. So the formula is determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Okay, here the first, this one should be considered as x1, y1, z1, and this is x2, y2, z2, and here it is x3, y3, and z3. So with that, let us substitute. So x minus the value of x1 is 1. Next y minus value of y1 is also 1, and z minus value of z1 is minus 1. So z minus of minus 1. Next x2 minus x1. x2 is 6. x1 is 1. So 6 minus 1. It is 5. Next y2 minus y1. y2 is 4. y1 is 1. So 4 minus 1. Which is 3. z2 minus z1 minus 5 minus of minus 1. So you have z2, it is minus 5 minus z1. z1 value is minus 1. So minus 5 plus 1, which is equal to minus 4. Next we have x3 minus x1. So minus 4 minus 1, which is minus 5. Next minus 2, that is y3 minus y1. y3 is minus 2, y1 is 1. Minus 2, minus 1, minus 3. Then z3 minus z1, that is 3 minus of minus 1. So 3 plus 1, it is 4. So this is equal to 0. So let us find. I've already thought how to expand this. Now we are going to expand this determinant along row 1. So here, expanding along row 1, we get x minus 1 into, neglecting the first row and the first column, we have 3 into 4, which is 12, minus 3 into minus 4, it is again plus 12. So 12 minus 12, next minus of, next taking the second element of row 1. So here when I consider the second element of the row 1, I should neglect the first row and the second column. So neglecting that, we get 5 into 4, which is 20, minus 5 into minus 4, it becomes plus 20. Then plus, writing the third element of the first row, so we have z plus 1 into, now neglect the first row and the third column, we have 5 into minus 3, which is minus 15, next we have minus 5 into 3, it is again minus 15, is equal to 0. So if you simplify, see here 12 minus 12, 0. 0 at x minus 1, it is 0. Again, if you see, this also will be equal to 0, this also will be equal to 0. So we got 0 is equal to 0. Here, what does this imply means? These 3 points are collinear. This is the equation which we have derived for non-collinear points. But here, once we are getting 0 is equal to 0, this implies that the points, the 3 points are collinear. What does this imply? That the given 3 points are collinear. Okay, let us take up the next question. Next question of the similar kind. Again, here we need to find the equation of the plane passing through the given 3 points. So again, we are using the same formula. So determinant of this is for x1, y1, z1. This is x2, y2, z2, and here this is x3, y3, and z3. Therefore, x minus x1. What is the value of x1? 1. Next, y minus y1 value is also 1. Next, z minus z1 value is 0. X2 minus x1. X2 is 1. X1 is also 1. So 1 minus 1 is 0. Y2 minus y1. 2 minus 1. It is 1. Then z2 minus z1. Z2 is 1. Z1 is 0. So 1 minus 0, 1. Next, we have x3 minus x1. Minus 2 minus 1. So it is minus 3. Then 2 minus 1. 1. Minus 1 minus 0, it is minus 1 is equal to 0. Again, we are going to expand along the row 1. So, expanding along row 1, we get x minus 1 into, neglecting the first row and the first column, 1 into minus 1 minus 1 minus 1 into 1, it is 1. Then, minus of y minus 1 into, now neglecting the first row and the second column, 0 into minus 1, 0. Minus 3 into 1, it is minus 3. Then plus z minus 0 is nothing but z. Now neglecting the first row and the third column, 0 into 1 it is 0. Minus 3 into 1 it is minus 3. Is equal to 0. So let us simplify this. So we get it as x minus 1 into minus 1 minus 1, which is minus 2. Then minus y minus 1 into 0 minus of minus 3. So it will be plus 3. Then plus z into 3 is equal to 0. So you have minus 2x, minus into minus plus 2 minus 3y plus 3, then plus 3z is equal to 0. Therefore, the equation is minus 2x minus 3y plus 3z. So you have 2 plus 3, which is 5 is equal to 0. So this is the equation of the plane passing through 3 non-collinear points. Now let us find what is the intercept form of equation of a plane. Okay, so let the equation of the plane be ax plus by plus cz plus b is equal to 0 and b should not be equal to 0. The plane, this plane makes intercept A, B, C on x, y, z axis respectively. So if you see this plane, this is a plane. The equation of this plane is ax plus by plus cz plus b is equal to 0. This plane is making an intercept on x-axis, y-axis and z-axis, and the intercept on x-axis is A, on y-axis is B, and on z-axis is C. Hence, plane meets x-axis at a point A, 0, 0 and y-axis at 0, B, 0 and z-axis at 0, 0, 6. Now, what I do is, I substitute this coordinates in this equation and find the value of A. So, substituting, and in the place of x, it is A, y is 0, z is 0. Therefore, we get A into A plus b is equal to 0. A into a, x value is a, plus b into 0, y is 0, z is 0. This becomes 0, plus b is equal to 0. This implies from this, if I find what is the value of a, this will be equal to, a will be equal to minus b by a. Similarly, when I substitute 0 comma b comma 0, I'll get b into b plus b is equal to 0. Therefore, I get b is equal to minus b by b. And similarly, when I substitute 0 comma 0 comma c, I get this as c into c plus b is equal to 0, which implies c is equal to minus b by c. Okay, now I am going to substitute all these values, that is a, b and c, capital A, b and c in the equation of the plane, in this equation. So I call this equation as 1, in equation number 1. So I get it as a, what is the value of a? Minus b by a into x plus, next we have b, that is minus b by b into y plus c, that is minus b by c into z plus d is equal to 0. From this equation, in the numerator, I will be able to take minus b common. If I take minus b common, I'll get x by a, then plus y by b plus z by c plus, sorry, here minus 1 we have, sorry, minus we have taken common, so this becomes minus 1. Since we have taken minus d common, here minus d, if we take common we get x by a. Here when I take minus d common, I'll get y by b plus y by b, and again when I take minus sign common here, I'll get plus z by c. So here when I am taking minus d common, I'll get minus 1 is equal to 0. Therefore, I get this as x by a plus y by b plus z by c minus 1 is equal to 0. Hence, the intercept form of the equation of the plane is x by a plus y by b plus z by c is equal to 1. So, this is the intercept form of the equation of a plane. What is that? It is x by a plus y by b plus z by c is equal to 1. Let us solve few problems on this. So the first problem here is find the equation of the plane with intercepts 2, 3 and 4 on x, y, z axis respectively. So we already know the equation, the intercept form of the equation of the plane is x by a plus y by b plus z by c is equal to 1. Okay, here 2, 3 and 4 are the intercepts made on x, y, z and z axis respectively. Therefore, a is equal to 2, b is equal to 3 and c is equal to 4. So it is x by 2 plus y by 3 plus z by 4 is equal to 1. Okay, so the LCM here, in order to find the equation, it is 12. So it is 6x plus 4y plus 3z is equal to 1. Hence we get 6x plus 4y plus 3z is equal to 12. It is the equation of the plane. Next question, find the intercepts cutoff. Means we need to find what is A, B and C value of cutoff by the plane. So they have already given this. They have already given the equation of the plane. We need to find the intercepts cutoff here. So here it is 2x plus y minus z is equal to 5. In order to find the intercepts cutoff, we need to reduce this equation in this form. X by a plus y by b plus z by c is equal to 1. Okay, so here in order to reduce in the form of x by a plus y by b plus z by c is equal to 1, I divide this entire equation by 5. So dividing the entire equation by 5, I get 2x by 5 plus y by 5 minus z by 5 is equal to 1. Next, in order to reduce in this form, I write it as x by 5 by 2, then plus y by 5, next plus z divided by minus 5 is equal to 1. Now, this as reduced in the form x by 8 plus y by b plus z by c is equal to 1. Now you can say what are the intercepts cut off. That is, the value of A is 5 by 2, B is 5 and C is minus 5. Okay. Next, find the equation of the plane with intercept 3 on y-axis. They have given that the equation of the plane we should find where it is making an intercept 3 on which axis? Y-axis, and parallel to ZOX plane. Okay, so it is parallel to ZOX plane. It is understood. It is not making any intercept. The plane is not making any intercept on x-axis and z-axis. So you have only y by b is equal to 1. So y by b value is 3 because the intercept made on y-axis is 3 is equal to 1. Therefore, y is equal to 3 is the equation of the plane. This is for today's class. In our next class, let us derive the equation of the plane passing through the intersection of two given planes and its problems. So